बिस्मिल्लाहिर्रहमानिर्रहीम। आज हम पढ़ने जा रहे हैं न्यूक्लियोफिलिक सब्स्टिट्यूशन reactions. Nucleophilic substitution reactions are of two types, SN1 reaction and SN2 reactions. तो पहले हम देखते हैं SN2 reaction and its mechanism. Before discussing SN2, I want to tell you about some basic terms. That is, what is nucleophile, what is electrophile, and what does substitution means. Now, nucleophile जो है, nucleo means nucleus, phile means to love. It means nucleophile is that group of atom which loves nucleus. And these group of atoms are like water. It has a pair of electron, lone pair of electron. Similarly, ammonia, a lone pair of electron, and OH negative, which has a negative charge. The nucleophile are the best electron donor. Similarly, halogens, chloride negative, bromide negative, and iodine negative are also nucleophiles. Because nucleophiles means the group of atoms which have the lone pair of electron or ions which are negatively charged and they have ability to give the electrons. Now, what is electrophile? Electro means electron, phile means to love. It means that thing which has ability to accept the electron or which wants to attract the electron towards itself, which is deficient by electron, like C plus, carbon plus is an electrophile. And what is substitution? Substitution means that one thing is removed and other thing takes its place. आपने एक चीज़ को हटा दिया, उसकी जगह कुछ और लिया है. Just like in case of football, one player is removed from the ground and other player gets its place. अगर कोई थक गया उसको बुला लिया जाता है और किसी फ्रेश को भेज दिया जाता है. तो this is the case of substitution reaction. And 2, यहाँ पर SN2 है, तो 2 stands for bimolecular. Bi means 2, molecules mean molecules. It means 2 molecules are taking part in the rate determining step or the slow step. ये छोटी छोटी सी टर्म्स हैं, बेशक इसको आप बाद में देख लीजिएगा. तो पहले हम SN2 मैकेनिज़्म देखते हैं, उसी में ये तमाम टर्म्स जो हैं ये डिस्कस हो जाएंगी. तब आपके लिए इसको समझना आसान होगा. चलें ये स्टार्ट करते हैं. SN2 मैकेनिज़्म. SN2 मैकेनिज़्म किसमें ये हमारे पास होता है? इन एल्काइल हैलाइड्स. एल्काइल हैलाइड्स में हमारे पास आ रहा है SN2 mechanism. Nucleophilic substitution reaction occurs in alkyl halide, and in case of SN2 we take primary alkyl halide because SN2 occurs in case of primary alkyl halide. Primary carbon, secondary carbon, tertiary carbon जो आपको पहले बता चुके हैं. So I am taking the example of methyl bromide. What? I am taking the example of methyl bromide. This is CH3 or R, and halogen जो मैं यहाँ लेती हूँ that is Br, bromide. So CH3 is alkyl and Br means it is a halogen. Okay. Now this is primary alkyl halide. इसमें अगर आप देखें you will see 3 kinds of atoms: carbon, hydrogen and bromine. Here the bromine is electronegative by nature. Electronegative means it has tendency to accept the electron or to attract the electron towards itself. ये जो bond बीच में बन रहा है इसमें से ज़्यादा जो electronic cloud है it is more towards bromine. So bromine takes up the electron towards itself. So what happens then? This carbon gets electron deficient. इसमें इलेक्ट्रॉन की कमी हो जाती है एंड दिस शॉर्टेज ऑफ इलेक्ट्रॉन इज डिनोटेड बाय पॉजिटिव साइन. To fulfill the requirement of this carbon, which is now electrophile, क्योंकि इसको इलेक्ट्रॉन की ज़रूरत है, what happens? A nucleophile, a strong nucleophile, OH negative, it attacks on this carbon. Why it attacks? It attacks on this carbon just to fulfill its duty, कि वो इसकी कमी को दूर कर दे. So this is OH negative is said to be as the attacking nucleophile. It is said to be as the attacking nucleophile. This is also a nucleophile Br, but this Br wants to leave after accepting the electron. So we say this Br here is actually the leaving nucleophile जो छोड़ना चाह रहा है. And all this happens simultaneously. Simultaneously means at a time ये बॉन्ड बनाना चाह रहा है और ये यहाँ से हटना चाह रहा है, बॉन्ड टूटना चाह रहा है. दिस occurs simultaneously in this slow step or the rate determining step. अब हमारे पास क्या होता है? When this happens, we get a transition state. In case of transition state, here the carbon is sp3 hybridized. In case of transition state, carbon का inverted हो जाता है formula, sp2 hybridization state में आ जाती है ताकि हर molecule को जगह मिले ठहरने के लिए. So this dotted line shows the transition state between carbon and OH and also between carbon and bromide leaving nucleophile. This stage or the state is called as transition. Transition means temporary. Transition state है, temporary है, not permanent. Now what happens? A time comes when this stage no longer exists in such a case. And what happens? A bond between carbon and strong nucleophile is formed. We get this product plus we get the leaving nucleophile Br negative. This is the case of nucleophilic substitution reactions. What happened? That the place of bromine जो है, it is taken by the OH. So this is a substitution reactions. And in this step, in case of slow step, two molecules are taking part. One is methyl bromide and the other is OH negative attacking nucleophile. Since the two molecules are taking part in the slow step or the rate determining step, that's why we say that it is a bimolecular substitution reaction. क्या होगा हमारे पास? Now the reaction kinetics will be, we say, the rate of reaction is directly proportional to the molar concentration of methyl bromide. इसकी concentration पर depend करता है and also it depends upon the attacking nucleophile. One molecule of this, one molecule of this. So 1 plus 1 is equal to 2. So we say that it is a bimolecular reaction. It is a bimolecular reaction, and in the slow step or the rate determining step, these two molecules take part. That's why it is said to be as the bimolecular or SN2 nucleophilic substitution reactions, and this occurs in case of primary alkyl halide. Thank you.